Hey everyone, my name is Rithik, and I'm going to be going over question 1 for week 14 of more sorting. So let's first go over the question. For taxes, you must submit a list of the ages of your customers in sorted order. So I'm going to make sure sorted order. Define age sort, which takes an int array of all the customers' ages and returns a sorted array. Assume customers are less than 150 years old. So this last part's super important to note because now we're creating a range. So we know that the age that it could possibly be is between 0 and 149 because they all would be less than 150. So when we're writing code, we can look at what's given to us right here. And we can see that they said 140 is the max age. We're creating a list of 150 size. And what we're going to do is we're going to go through it and say, okay, for every single age, we're adding 1 in our ages array. So let's kind of run through that here. Let's say we have 5, 7, 8, 10. Then what I'm going to do is we're creating a histogram as the name of the function implies. So I'm going to have 1, 2, 3, etc. And let's say this is 5. Let's say this is 7, 8. Let's say this is 10. So I'm going to put 1, 1, 1, 1. Let's say I added a new one, 10. So add another one on top of that. So now we're creating a histogram where we're tracking how many of each age do we have. So the next step is for us to sort it. So before we go into writing code, let's think about what should we do. So all we need to do is sort a list of numbers. We just need to sort these different ages, and we know that there's going to be some sort of repetition, presumably. And that makes our job a lot easier because now what we can do is we can start from the left. So start from 1 and just go, start from 0. And we just need to go through every single one. And let's say 5 has 7 instances, 7 has 8. So all we need to do is be like, okay, 0 has 0, 0, 0, 0. Now 5 has 7 customers that have age 5. So we can just do 5, 5, 5, 5, 5, 5, and 7 times, right? So one more. And then we go to 6, which has 0. Then, 6 has 0. And then 7 would have 8. So I'd put 7 times 8 times. So the idea of it is to go through our histogram, and because we're counting how many of each age we have, we can just add that in however many times and have our end of our final array. So let's write this in code. Let's not delete that actually. Let's move this to the side. Cool. So the first step is we just want to run our histogram. So I'm going to do int of an array age counts is equal to this function histogram of ages. So now we have the first step. We have our histogram. We have the number of each one. So now let's create our result. So int result is equal to new int. And the question is, what size do we make it? So we know that there's going to be 150 possible ages. So similar to here, we can copy that over. And so it's going to be max age, which we know to be 149, and just make this 150. Another way of doing this, if you don't want to hard code it, is by doing age counts dot length. Personal preference, either one, but in this case, we can just go with age counts length and just stick that in here. Okay, so now we have our result array and we have our age counts. Now let's start iterating through. So I'm going to say int index is equal to 0. So this is going to be used for our result array. I'm going to iterate through our ages for int age is equal to 0, age is less than max age, which our max age would be 150. So in fact, why don't we just put 149 here, and this is actually 150. 150 because we want to get 149, and we would do age plus plus. And now create our brackets right here. So within our for loop, what we want to do is we want to basically say, all right, we want to add in that number however many times are in that bucket. So let's say for int count is equal to 0, count is less than age counts. And we're going to grab that age. And looks like I'm running out of space. I'm going to have to move this to the side a little bit more. Or let's move this down. So now what we're doing is we're saying, okay, there are 5 instances of 5 as an example. So we're going to want to go through every single one. And as usual, count plus plus to complete that iteration. And now the last step is to figure out what's inside of this. So all we need to do is do result index is equal to, well, we want to have the age, so we can just do age. And lastly, we want to increment our index by doing index, excuse my handwriting, index plus plus. And that's pretty much it. So all we need to do at the end is just return result. So let's go over this one more time. So we created an array where we have the histogram. So in that histogram, we have numbers 0 to 149, which is 150 numbers. Then we're going to create a result of that same size. And we're going to say for every single number, since our sorted array and unsorted array must be the same length, we can just reuse that. Now we're going to start with index 0 for our new result array. We're going to iterate through all the possible ages, and we have the count of each age. So we're going to add each of those ages however many times that we found them in the histogram function. Cool. So let's move on to the next question. So time passes and your restaurant's doing really well. Unfortunately, our robot overlords advanced medicine to the point where humans are now immortal. How can we extend the algorithm to accept a list of any ages? So for this question, when I was this question, I thought of radix sort, because radix sort is very commonly aligned with numbers in terms of being able to look at specific digits and being able to use that to our advantage, because we want to reuse our algorithm without having to rewrite the whole thing with merge sort, quick sort, etc. So let's rewrite this function, or let's describe how we would advance this function to include immortal ages. So now we no longer know that 150 is the maximum age. So now with that case, what we need to do is we need to look at all of our ages. So let's just create an example here. Let's say we have 180, 199, 347, 521, etc. So how can we sort these numbers? Well, we need to create some sort of maximum to use this function above. Before we said it was 149, but let's think of maybe a different way we could use that. What if we use radix sort in the MSD or LSD style? Either of them would be applicable depending on whether you want to use space or time. So let's look at LSD first. So we're going to chop off the last digit and sort it by that. So now we'd only have 10 possible buckets instead of the 150 from before. And this way we can reuse our algorithm for every single digit. Then we move on to the next one, and then the next one, and so on and so forth. And the cool thing is that if we do MSD right here, we can actually make our function run even faster by running the optimization that we learned about, where you can run, instead of looking at each digit individually, we could perhaps look at the first 2 digits. And that would allow us to run this algorithm a little bit quicker than what is the worst case. So let's say we can cut this off at 2 digits, and then now we would have 100 possible buckets, and that might run a little bit faster because we wouldn't have to iterate through every digit. And yeah, so that's pretty much how we would extend it. We would use radix sort as our solution and look at digits individually or in small clumps, because that would allow us to constrain ourselves to certain values rather than having an infinite range. So how would we be able to use this type of sort? So the base function for having a radix sort is having a radix. So what that means is that you need to have some sort of combination of symbols. You need to have something to iterate through, like whether they're characters, whether they're letters, numbers. It needs to have something for you to break down to individually. Think of it like you're breaking it down a question and you're solving small parts of it and slowly building the final solution. Whereas something like an object might be a bit more difficult. And that kind of ties into the next question, 1.3. Why don't we always use it? And the reason why is because not all objects are radixes. So the big example is, let's say I have an object of a dog. It might be a bit hard for me to say, oh, like I'm going to break it down into specific small parts. So having an object that is not easily broken down to small parts, it might make it a bit more difficult to run radix sort because we don't have a base. And yeah, so basically the main idea for the last question is we don't have any way to individually compare parts of an object. Obviously, this is depending on some objects, which is why radix sort is not always used in that fashion. But yeah, so the main idea for this type of question is understanding radix sort, knowing how to break down a question like this, where you can look at a question, they're giving you the specifications, but you have to create your own sorting algorithm, which might not be as obvious because it's not the traditional sorting algorithms, but we're able to use that and build off that intuition with MSD and other radix sorts as well. Cool, thank you so much, and feel free to ask your CSM TA if you have any more questions. Thank you.